In this video, we are given that W1 and W2 are subspaces of vector space V. We're further told that the intersection of W1 and W2 is the set that just contains 0, and that W1 plus W2 is V, and W1 plus W2 is defined to be the set of all W1s plus W2s such that W1 is in W1 and little W2 is in subspace W2. Okay, the usual way. Now, I want to show that any vector in V can be uniquely written as W1 plus W2, where W1 and W2 live in the right places. Okay, so let's try to prove this. Let V be in V, which is equal to W1 plus W2. Okay. Suppose V is equal to little w1 plus little w2, and so V can be written as little w1 plus little w2, and V can be written as w1 prime plus w2 prime. I want to show that W1 equals W1 prime and W2 equals to W2 prime. Okay, so now if we equate these, W1 prime plus W2 prime, and we subtract in this way, now we clearly know that this is in W. I meant to say W2. And this is in W1. Okay, so what we have is that this element in W1 and this element in W2 are the same. But the only thing that's in both of them, by definition, the only thing that's in both of them is 0. Okay, the only thing in both of them is 0. So this statement here, it implies that W1 minus W1 prime, which equals W2 minus W2 prime, are in W1 intersect W2. Okay, because they're equal. Something in W1 equals something in W2. That something has to be in both W1 and W2. Okay. Well, the only thing in both of them is 0. That means this one must be 0, and this one must be 0. W2 prime is first. And this says that W1 equals W1 prime, and this one says W2 prime equals W2. So what we conclude, W1 prime, we conclude that W1 plus W2, W1 plus W2 is equal to anything that equals W1, like W1 prime plus anything that equals W2, such as W2 prime. And this is what we wanted to show, that these two representations for V were exactly the same. You know what I mean? We could have had V is equal to, I don't know, V star plus V minus V star. That equals V. Or we can have V equals to V double star, which doesn't equal V star, plus V minus V double star. We could have had V equaling this element in W1 and that in W2 and this in W1 and this in W2. Okay, and they wouldn't have been equal. But the fact that the intersection only contains the zero vector ruled out cases like this. So it does turn out that these had to be the same exactly. That is, V is uniquely expressed as W1 plus W2. No, nothing else would work. If it equals W1 prime plus W2 prime, rest assured that W1 equals W1 prime and W2 equals W2 prime. That completes the proof of this theorem. If you like videos like this, please subscribe to my channel. As I always wish everyone a great day and watch and learn.